I think we are not done. We are not done. It seems to me we must also get these times as well. That will imply we'll have to look at the general solution, and by having the general solution, we just add 360 degrees times n. We just add 360 degrees times n. And here will be 323. I'm trying to rectify this. 323. If we subtract 36,87 from 360, we've got 323,13 plus 360 plus 360 degrees times n. Now we have divided this value by 18 to get 17,95. Therefore, we must divide this 360 by 18. So if we divide 360 by 18, we get 20 times n. Similarly, we're going to do the same here. Divide, this will be plus 360 degrees times n. We're going to divide that 360 by 18. We're going to have 20 degrees times n. Now, you will see the importance of, which will be 12,05 plus 20 degrees times n. You'll see the importance of this general solution here. Right. Now, I've just received the question that I'll respond to. You see, when I was doing this problem, I did not use the general solution. So I fell into the trap because I don't have only two solutions. I've got 1, 2, 3, 4 solutions. So the two solutions that I'm having here are not giving me the full marks. Hence, I'm adding 360 degrees times n, because originally I had the trigonometric ratio of sine there. So I'm rectifying this to get the other answers. I've actually fallen into the trap by not writing the solutions, the general solution. So my answer to the question is, in this case, we must write the general solutions. Right. We are not told to write the general solution, but when I look at this problem, I realize that we have got 4 solutions. Without a general solution, it's really difficult for me to give the other solutions in this problem. So I've rectified it and add 360 degrees. I went up to this step, so I'm having 12 hours plus 20 degrees times n. Now, I now go back. Remember, n must be an element of integer. Now, I'm going to make n, in this case, n cannot be negative, because if I've got negative here plus 12, I'll get negative hours, and we don't have negative hours. But if I substitute n with 1, 20 times 1 will be 20, plus 12, that will be 32. Now let's go back to our problem and see. Here I'm expecting the value that is, we've got 30 here. I'm expecting a value that is a little bit greater than 30. And indeed, my answer here in my general solution, when I substitute n by 1 times 20 plus 12 is giving me 32 hours, which is that solution there. Let's see if we can get another solution. Substitute n by 2 20 times 2 is 40. 40 plus 12, that is 52. Let's look at our diagram again. You see now its interval goes up to, I think it goes up to there. It doesn't go beyond 50. So that falls outside the restriction that we are having. But now let's look at our 17,95. For if we substitute n by 1, 20 times 1, that will be 20. So we said this will be approximately 18. So 20 plus 18, that will be 38. We go back to our problem and see if we've got the value there. We go along this line, we go along this line. Here, the value is 35, and obviously that must be 38. So that has been solved. Right. Now I understand why am I doing the general solution, because there are practical application of that in a real life situation. I promise to go back to that problem because we did not finish the whole problem. We ended up, I think we ended up solving only one part. Yes, I think our problem was we had the solution for sine x is equals to -1/2, but we did not have the general solution for sine x is equals to 1. Right, let's go for it. So for sine x is equals to 1, step 1, we've got to find out the quadrant. This seems to be a funny problem. The ratio is positive. Okay? Now, in which quadrants is cosine positive? That must be in the first. That must be in the first and the second quadrant. And the next step, step 2, what do? We look for the reference angle. We are going to refer to this angle to generate the solution for this problem. Now the reference angle becomes, we press second function or shift and then arc sine of 1 close bracket, and we get the answer of 90 degrees. Now, if we look at our sine graph here, the reference angle is there. We look at that and we draw the line there. It seems like we are going to have the value that is more than 360. So we should be comfortable with 90 degrees only. We'll be able to generate all the solutions for that problem. So the solution for this problem will be x is equals to 90 degrees. So let's demonstrate that. We are in the first and the second quadrant, but now the reference angle is here. From here to there, which is 90 degrees. Okay. And folks, is the same as saying we are having the ratio as positive in the second quadrant. And when we put our reference angle in the second quadrant, it will be the same line, this line. So putting one line will suffice. Now, the solution for that will be, we start from the positive x-axis up until we touch this arm. That will be the solution, but we can go for any number of revolutions. So the solution will be x is equals to 90 degrees plus 360 degrees times n. We don't have to forget that n must be an element of integers. All right, I think we are fine up to that. We are done with that question. Happy? All right. Now, let's go to the next question. And